Do you need a paper towel, Luke? Come get it. Okay, so let's go over this practice quiz. I want you to listen carefully here because I'm going to show you, Gianna. Number 1, we have 3 3/5 plus 2 5/7. Now, do the denominators match?
No.
What's the second question, Grace?
Are
Are they both prime?
Yes, yes.
They are. So how do we get the LCM?
Times them. Wait, I mean multiply.
Multiply them. 5 times 7 is 35. So 35 is our new denominator because both of our denominators are prime. Our unit multiplier here, 5 times 7 is 35, so it's 7 over 7. And 3 times 7 is 21. 7 times 5 is 35, so our unit multiplier is 5 over 5. And 5 times 5 is 25. Now I can add these. This is 46 over 35. And 3 and 2 is 5. But are we done? Autumn, are we done? Why not? What is this? An improper fraction?
I know what to do.
Very good. What do we do?
So you divide them?
How many 35s are in 46?
What? And there's
1.
11 left over.
Yeah. There's 1, and how much is left over? 11 is left
11,
over.
that is, yeah.
And 35. So how many 35s are in 46? 1. When we take that 135 out of 46, we have 11 left over, and our denominator stays the same. Now we add our whole numbers, 5 plus 1 is 6, and 11 over 35. Who got that one correct? So we need to practice that then, huh? So let's practice. Yeah, you got a question?
Mm-hmm.
So let's practice that over here. So I'll make this one number 5. Do those 3 the same way.
Good morning, ma'am.
Good morning.
Wait a second.
How are you?
Good. My legs are tired from marching a parade.
Couldn't make it to the parade. Coffee for me? there's no more.
Luke, you still working? Okay, let's take a look at number 5. 2 3/4 plus 3 1/2. Do my denominators match, Micah? Is one a multiple of the other, Riley? Which one's a multiple of the other? 4
Oh, yeah.
is a multiple of 2. Because if you say your two multiples, 2, 4, 6, 8. 4 is one of them. 2, 4, 6, 8. See that? So our new denominator will be the larger one. So this one just stays the same, doesn't it? 2 times 2 is 4, so 2 over 2 is our unit divider. Now we can add 3/4 and 2/4 is 5/4. And 2 and 3 is 5. Do we need, are we finished, Gianna? Why not?
Because it's
An
proper fraction.
very good. This is an improper fraction. 4 goes into 5 once. How many 4s are in 5? Just 1. Take that 4 out of that 5 and you have 1 left over. And our denominator, I was about to put 5, our denominator stays the same. So we have 6 1/4. Raise your hand if you got that one correct. Did you make it? What error did you make?
I just added it wrong. I
Okay,
put 2 instead of 3.
gotcha. Okay.
Oh, I subtracted instead of
Uh-oh. Mr. Micah, did you attempt this? Now, you have to have other sheets of paper underneath this. Did you see how you can't really read this? So you have to have several sheets of paper underneath it, and then you have to spread it out. You can't read it, but you didn't rename them. You have to rename them. Okay, so let's take a look at number 6. Number 6 is 5 2/9 plus 3 11/12. Did you add these, Ms. Riley? Okay. Emily, do the denominators match? Are they both prime? I'll skip that question. And is one a multiple of the other? So how do I have to find the LCM, the new denominator? Factor trees, that's right, factor trees. So I'm gonna take 9 and 12. 9 is 3 times 3. 12 is 2 times 6. And 6 is 2 times 3. Riley, did you make factor trees? Very good, very good. And what did you get from this, Riley? What number did you get?
I got
Which one has the most 2's?
12.
So I take these 2 2's. And which one has the most 3's?
9.
So I take these 3's, not this one, huh? I take these 2 3's. And what is 3 times 2 times 2 times 3 times 3? Did you not get these factors, Brian?
I did 4 times 3 instead of 6, but I got the same answer.
Okay, so you have to break it down until they're primed, huh? Yeah. Okay, so we see that 36 is our new denominator because that's our LCM, right? So we're going to put 36 here and 36 here. 9 times 4 is 36, so 4 over 4 is our unit multiplier, and 2 times 4 is 8. 12 times 3 is 36, so 3 over 3 is our unit multiplier, and 11 times 3 is 33. Now that the denominators match, I can add. What did you get, Emily? When you added these two together? Very good. Am I finished, Emily? Why not? Right. How many 36s are in 41, Emily? And if I take that 36 out, how many are left over? 5. That's right. So now 8 plus 1 is 9, and 5, 36. Who got that answer? Good job. Good job.
Yeah.
If you didn't, do you see your error?
I already wrote my
Okay. You've got to rename them, Micah.
I got 9 and 4 36.
You had 9 and what? 436?
Yeah.
Well, take 41 minus 36. Put that into your calculator.
I had 11 36. Got to use mine.
You didn't rename them. Table. Okay, let's take a look at number 7. Number 7 is 3 1/3 plus 2 4/5. 3 1/3 plus 2 4/5. Luke, do the denominators match?
No.
Are they both prime?
No.
Is 3 prime?
No.
Can 3 be broken down anymore, Micah? What time, Luke, I'm sorry. Luke, what times what equals 3? Nothing, huh? No. 3 is prime. Can 5 be broken down, Luke? What times what equals 5? They're both prime then, aren't they? If they're both prime, what do I do to get my new denominator?
Make prime factor trees.
No. Remember, do they match? If they match, we can go ahead and add or subtract them. If they don't, we say if they're both prime, we multiply them by each other to get our new denominator, our LCM. Do you remember that, Luke?
Yeah.
So now I rename them. 5 over 5 is my unit multiplier. So this is 5. 3 over 3 is my unit multiplier. So this is 12. And that gives me 17 fifteenths. 17 over 15 is improper, isn't it? So how many 15s is 17? 1 with 2 left over. So my answer is 6 and 2 15ths. Who has this answer? Very good. Do you see your error? You see your error? Okay, very good. Let's go to number 2 now. We've been practicing problems like number 1. Let's go to number 2 now. We have 6 and 1/9 minus 2 and 4/5. Do my denominators, I'm adding and subtracting. So I ask myself, do my denominators match? Do they match, Grace? Are they both prime? Is one a multiple of the other? No. 5, 10, 15, 20. 9's not a multiple of 5, is it? So what am I going to do, Grace?
Factor trees.
Factor trees. 5 is prime, but 9 is 3 times 3. Right? So which one has the most 3's? 9. Which one has the most 5's? 5. And that equals 45. 45 and 45. This is 5 over 5. So 1 times 5 is 5. This is 9 over 9. So 4 times 9 is 36. Now, I have to subtract. What is 5 minus 36, Luke?
5 minus 36 is
5 45ths minus 36 45ths. How much is that?
31.
If I have 5 cookies, can I give you 36? If I have 5, I can't give you 36, can I? Riley, you see this? If I have 5, I can't give you 36, can I? So I have to borrow 1 from here, don't I? And I can put that 1 right here, can't I? Now, 1 times 45 is 45, plus 5 more is 50 over 45. I turned this mixed number into an improper fraction. Now carry this one over here. Now can I subtract, Lucas? Luke? If I have 50 cookies, I can give you 36, can't I? And that equals 14 over 45. And 5 minus 2 is 3. Can this be reduced? No, 14 is 2 times 7. 45 is 3 times 15, which is 3 times 5. Do they have anything in common? Do 14 and 45 have anything in common? No. This one has a 2 and a 7. This one has a 3, a 3, and a 5. So it can't be reduced. So my answer is 3 and 14 15ths. 14 45ths. Anybody get that answer? So we need to practice that some. You did? Very good. You did, but you told me you didn't know how to do that one.
Oh yeah, I figured it out once you did the first one.
Gotcha.
I got 7, 14, 45.
But did you check each step, Gianni? You should, as I do it, you should be checking each step.
I was just watching you do it. Oh.
Good job, Emily, finding her error. Good job. Okay, so let's try another one. Let's try this one. What's our new denominator, Owen? You have a question?
I just want to know when we were going to eat brownies.
Well, not right now. Because in just a minute, okay? We're gonna do it right at the beginning of language arts, okay? Okay. What's our new denominator? Well, let's ask ourselves, do our denominators match? Hold on. Do they match? No. Are they both prime? Jane? Is 11 prime? What times 1 equals 11? Not counting 1. So 11 is prime. Is 9 prime? What times 1 equals 9? 3 times 3, that's right. So they're not both prime. They don't match, they're not both prime. Is one a multiple of the other? Starting with 9s. 9, 1 9 is 9, 2 9s is 18. 11 is not a multiple of 9. So how do we have to find our new denominator, R?
Multiply.
What, R?
Multiply.
No, make factor trees. We multiply if they're both prime. So 11 is just 11. 9 is 3 times 3. 9 has the most 3s. 11 has the most 11s. And we get 99. Yes, ma'am. You have a
I
question?
didn't need to do the factor trees because I knew 3 times 3 was 9, and then I just multiplied it.
That's very good, very good. Yes, you can, sometimes you can do this in your head. So you do end up multiplying them because they don't have anything in common. So this one is 9 over 9. 2 times 9 is 18. This one is 11 over 11. 7 times 11 is 77. Now, what is 18 minus 77, Grace? If I have 18 cookies, can I give you 77 cookies? No. So I have to borrow. I have to borrow one from here. So I'm going to make this a 4 because I'm taking one away from it. And I'm going to put this 1 right here. Now I have to convert this mixed number to an improper fraction. 1 times 99 is 99, plus 18 is 117 over 99. Let me make that a little bit smaller there, or a little bit higher. I can't make that right. 117 over 99. Now bring this one over. 77 over 99. Now, what is 117 minus 77? Gianna? Wait, look on your paper. I want you to do it with your calculator. Look on your paper.
I don't think I wrote it this time. So, 117.
So you made an error? You see your error?
And plus, I wrote down minus, but I still did plus, but it came to that.
So you've got to look for that. What is 117 minus 77, Brian? 40. Is that right? 40? Yep. 40 over 99. And 4 minus 3 is 1. Now, is that a proper fraction or an improper fraction?
Proper.
It is. Can it be reduced? It can't be divided by 2. This one can, but this one can't. This one can be divided by 3, but this one can't. This one can be divided by 5 and 10, but this one can't. So let's take a look at 40 and 99. This is 2 times 20. 20 is 2 times 10. And 10 is 2 times 5. 99 is 3 times 33. And 33 is 3 times 11. Do they have anything in common? Yes, ma'am. You have a question?
No, I'm stretching.
Oh, do they have anything in common? Do they have anything in common? No. So we cannot reduce this, so this is our answer. Now, let's go over number 3 very quickly. Number 4, because you're going to practice this for homework some more. We have 2 2/3 times 5. A mixed number times a fraction. Times a whole number, I'm sorry. A mixed number times a whole number. What do I have to do first? Who remembers what I have to do first? Emily? What do I have to do? Do I have to convert this to a mixed number to multiply? I mean, an improper fraction? Remember that? This is 2 times 3 plus 2. 2 times 3 is 6, plus 2 more is 8. A denominator stays the same. You remember that? You remember that from homework? We have to turn our mixed number into an improper fraction to be able to multiply it. Now, what is 5? Is that a numerator or a denominator? Numerator. You have to know that now. This numerator and this denominator cannot cancel, so I say 8 times 5 is 40, the denominator is 3. Now how many, it's an improper fraction, how many 3's are in 40? How many 3's are in 40? Everybody should be finding out. Luke, are you doing it?
Oh, so for the calculator?
We're just about finishing up, so you're probably going to be a little bit late on that.
Oh, I was counting.
Autumn, how many 3's are in, yes, we're supposed to use our calculator. How many 3's are in 40, Autumn? 13. How many 3's are in 40? 13. If I take those 13 3's out, what is 13 3's? What is 13 3's? How do you find out what 13 3's is? Very good, Emily. That's how you find out. You punch it into your calculator.
4.
13 3's is not 4. If I have 13 sets of 3, what do I have?
39.
39. If I take 39 out of 40, how many do I have left? If I take 39 out of 40, 1. And my denominator stays the same. I think I might need to give y'all extra homework on this, because y'all are not tuning into this or something. Let's go to page 182. And let's do number 2A and 3A. We're going to run a little bit over, guys, just a few minutes, okay? Okay, page 182. 2A and 3A. As quickly as you can. Show your work. 182.
We already did one.
I'm sorry, I thought we did to 181. What was our homework? I was looking at Monday's homework. What was the last page we did? Gianna, are you tuning in?
Yeah.
You're not tuning in. You're looking outside. And are you answering my question? What was my question?
What was the last page of homework?
What was it? You're not looking. It was 185?
Yes.
So I'm assuming we turned to 186.
Nope. Nope. You're going to have to redo 184. Get out, just on the same piece of paper that we've been working on, do number 1 and 2 on page 184. On page 184, do numbers 1 and 2.
We already did that.
I want you, what did I just say to do on that piece of paper that we've been working on? On the same piece of paper that we've been working on, do numbers 1 and 2.
So you want us to take out the test paper that we already did and just put the answer that we haven't?
No, I want you to work it again. Because you're going to have this on a quiz on Wednesday, but y'all are struggling with it right now. Do numbers 1 and 2 quickly.
1A and 2B or 1A and 2A?
1A and 2A. I mean 1A and, yes, 1A and 2A. First thing you have to do when multiplying mixed numbers is to turn them into improper fractions, right? That's the first thing you have to do when multiplying mixed numbers. You have to turn them into improper fractions. Now, the next thing that you do is you multiply. But when we start to multiply, we have to cross cancel. This is a numerator, and it always has to be a numerator and a denominator. Now I see that 2 can be divided by 2 and 8 can be divided by 2. But 12 and 8 can also both be divided by 2. Good morning. So let's do 2 divided by 2 is 1. 8 divided by 2 is 4. Now I have to continue looking. This is 1, so it can't be reduced anymore or canceled anymore. But 12 and 4 are both divisible by what? 4. 4 divided by 4 is 1. 12 divided by 4 is 3. Now we multiply our numerators. 1 times 3 is 3. Our denominator is 1 because there's nothing to multiply by. And 3 over 1 equals 3. Who got that answer? Very good, very good. Okay, now let's take a look at this. We have 35 eighths times 5. 5 is my numerator and 35 is a numerator. They can both be divided by 5, but they're both numerators. So it doesn't matter. Can 5 and 8 be divided by the same number? No, and 35 and 8 can't. So we say 5 times 35, let's see, 5 times 5 is 25. 175 over our denominator of 8. Now we have to change this to a mixed number. How many 8s are in 175? Each person should figure this out. When I ask this question, I want everyone to try to figure it out. How many 8s are in 175? Unless you've gotten it correct. How many 8s are in 175?
21.
21. Okay, now, if I take 21/8 out of 175, what do I have left? Well, what is 21/8, Luke?
Um, 7/8.
No, 21/8 does not equal 7/8. What is 21/8? What is 21 times 8?
168.
168. Where's your calculator? I do not want you to put your calculator away. Luke, take your calculator out. Well, I'm going to wait now. Now, Luke, what is 21/8?
168.
Now, if I take that 168 out of 175, what do I have left?
7.
7. And what's my denominator?
8.
8. So 7/8 is a part of our final answer. But what I was asking you is, what are 21/8? So you have to listen to the question, huh? So this is the answer. So now, let's go ahead and get our homework into our agendas. Now, you're going to have a quiz on this on Wednesday. The first thing I want you to do is I know that 184 is already done, but I suspect that it might not be done correctly because y'all are having trouble with this.
No, I really have no idea what I'm doing with it.
And so I want you to redo this on a piece of paper, and I'm going to pick it up. And I'm going to grade that. Now your homework is going to be on, your test is going to be on adding and subtracting mixed numbers. Just what we did today. So you need to study this and practice it. And then it's going to be multiplying fractions and mixed numbers. That's this. I don't know why I'm making these capitals here. There's no reason. So you have to study that. You're going to complete this and turn it in, and then you're going to, this will be practice for this, this will be practice for this, and you have to study adding and subtracting mixed numbers. Yes, ma'am.
Wait, so is the test only on adding and subtracting?
No, look what's written underneath test. You see where the word test is? It says adding and subtracting mixed numbers, and then what does it say under there?
Multiplying fractions and mixed numbers.
All of that is on your test. Does that make sense? Okay. Thank you. Sarah's going to be really happy about those thin mints. Hey, Miss Diane, would you like some Girl Scout cookies? Oh, no, you don't. Never mind. I don't know.
I love some, but no one can have it.
Do you have the?
Oh, yes. Yes.
Because I'm going to have a whole.
I didn't realize I had it on